right now this topic that Volker has is a new upcoming topic that I'm sure is of a lot of interest to many of you. Volker's come up with a proposal for a new paradigm with a map-reduced type of functionality. Welcome.
Thanks, Alistair. Thanks for the introduction, and it's good to be back here in Toronto. So thanks for the warm welcome. So what I want to talk about today is about a work that I have embarked on since I left IBM about 1.5 years ago in Berlin with my group there, but also a collaborative effort that brings in a couple of other groups in Berlin in the field of massively parallel processing and using this currently rather hyped up or new paradigm of map and reduce, seeing the deficiencies that it has, and the goal is to embark on a systems building effort that we have started in the last year that we will grow to, which is a good thing always, in my opinion, for educating students to actually build a physical system to get hands-on with some experience, and then try to add to the state of the art in that space. Before I go in more detail into that, just maybe putting Berlin, or particularly the Technische Universität Berlin, on the map. So I'm sure all of you know Berlin as the capital of Germany with roughly 3.5 million inhabitants. What's maybe also interesting, maybe many of you do not know that much, particularly because of the history of Berlin being this divided city and being a little bit on the sidelines of science and economy. In the last 20 years since German unification, a lot of things have happened, and Berlin actually has become, again, a major science location in Germany. There are about 130,000 students in Berlin at 27 universities. There's a lot of research institutes like the Max Planck, Helmholtz, Leibniz and Fraunhofer and Hertz institutes are there with a total of 70 institutes with 50,000 researchers. And there's a big technology park that's fostering a startup climate where there's another 15,000 researchers, but also 800 tech companies, small companies that have been founded, and a lot of them actually in the information technology and biotechnology field. TU Berlin, the Technische Universität Berlin, is one of the leading science universities in Germany. Actually, TU Berlin has a long history, as I like to say, of doing rocket science, in the sense that actually the very first rocket scientist came from TU Berlin. Werner von Braun is actually a graduate of TU Berlin, who ended his work on rockets, which eventually led to the Apollo program. And TU Berlin has a total of 8 Nobel Prize winners among its alumni and professors, around 300 tenured professors, 2,000 postgraduate students, around 2,000 student assistants or PhD students, and 27,000 students as a total in the master's and bachelor's program. The school that I'm working at is the School of Electrical Engineering and Computer Science, where we have 2,500 students and in the order of 50 tenured or chaired professors. Just a quick overview what I have embarked on with my group in Berlin is have several research areas that I'm looking into, from information modeling to business intelligence, but of course my standard topics are query optimization and query processing. And currently I'm also very interested in new architectures because we're experiencing the paradigm shift in computer architectures, particularly for data management, that I'm sure you are experiencing, and that will give rise to new database systems or ways of how we interact with the data. And of course applications is a big area. What I'll talk about today, there's a couple of projects like projects in social network analysis, projects in application areas like analysis of the public transportation system in Berlin. But I'll today talk about what I call the Stratosphere project, which is a project about information management on a infrastructure as a service or platform as a service, massive scale-out architecture for massive parallel analytics. So the trends, if we look at the trends that we are seeing in that field, nowadays we see this trend because of Moore's law hitting this wall with respect to integration and frequency, this trend of massive parallelization. We also see this trend of virtualization becoming more and more important, particularly in the context of cloud computing and in general this service-based computing paradigm. And this has been reflected also very large actually in the database community. So in the large VLDB, in the last VLDB conference, Phil Bernstein and others had a panel on web-scale data management, where web-scale data management was defined as this massively parallel scale-out data management, on the one hand for analytics, BI, but also operational with eventual consistency guarantees and some different architectural shifts in traditional database systems, and particularly also with respect to cloud computing, the issue of multi-tenancy. So this is an environment that is currently becoming more and more important. This is also supported by the Claremont report, which is a report that leading database researchers created in actually 2009. In Claremont, there was people like Michael Stonebreaker and Laura Haas and others, which identified as the biggest challenges for the next couple of years in database research, or the big trends. On the one hand, the need to re-architect database management systems with respect to, on the one hand, massive parallelization on commoditized hardware, so the scale-out architecture. On the other hand, continuous optimization, that means having an adaptive system that takes into account the state of the current execution, and not just per single query, but over the entire workload, and continuously adapts query execution, and a much tighter integration of optimization, runtime, and workload management than it is carried out in today's architectures. In addition, there's this trend towards a service-based everything with respect to programming model and also combining structured and unstructured data. And this is the area that this Stratosphere project that we have embarked on TU Berlin and we're going to grow in the next year is settled. So what we want to do is we want to explore the power of a massively parallel virtualized platform, or nowadays probably would say a cloud computing platform, for complex information management applications. Looking into a database-inspired approach to analyze, aggregate, and query both textual and structured or semi-structured data. So the goal here is really to research and prototype a web-scale data analytics infrastructure. And if we look at this system, how it's layered, so we're looking at a basis which is really an infrastructure as a service, so a massively parallel virtualized environment, on top of which we are researching and prototyping the Stratosphere query processor,